The horizontal and vertical equations shown in the video are representations of the conics on the graph. So there's different types of conics. One of them is parabola, another ellipse, hyperbolas, and circles. So first we're going to go over parabolas, and there are two kinds, horizontal and vertical. First we're going to be going over horizontal. So for horizontal parabolas, your parabola is going to be either facing to the right or to the left open end. And here, you're going to be crossing the y-axis. So for a parabola with a horizontal line of symmetry, the equation we're going to use is x minus h equals 4p y minus k squared. And the vertex of this will be h and k, which you can obviously find here. The focus of this will be h plus p k. So a parabola with a vertical line of symmetry is obviously going to be crossing the x-axis with the ends opening up or the ends opening down. So finding this parabola, this vertical parabola, you're going to need the equation x minus h squared is equal to 4p y minus k. It's similar like the last one, the horizontal, except here it's squared as here it's not. So the vertex for this will be also h and k, which can be found here. And the focus is going to be different from horizontal, and this is going to be h, k plus p. So as you might have noticed, each equation has p right here, and what p is the distance between vertex to focus. So in this horizontal parabola, for example, right here, from vertex to focus would be 1, 2, right. So p would be equal to 2. So another one of our conics is an ellipse. An ellipse is basically an oval on your graph, and the endpoints right here, these are called vertexes or vertices. And this axis right here, known as your x-axis, it will be called your major axis. And this will be called your minor axis, only because this is a horizontal ellipse. So the point, your origin is obviously right here, and the point from one of your vertex to your origin, this will be called A. And the point from your origin to half of the oval or half of the minor axis will be called B. Here in the middle between the origin and the vertex, this is your focus, be found on each side. And from the origin to the focus, this is called C. So the equation for a horizontal ellipse is going to be x minus h squared over a squared plus y minus k squared over b squared is equal to 1. The vertices are equal to h plus a k. The center will always be hk, and the foci can be found using h plus or minus ck. So this vertical eclipse is basically going to be the same thing as a horizontal. It's going to be labeled the same, except if you move your ellipse this way. So this would be your minor axis, while this is your major axis, but this is still A, this is still B, and this is still C when you're looking at the minor and major. So to find a vertical, what you're going to use is x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And this is going to be the same thing as horizontal, except right here you can see how we switched a squared and b squared. For the vertices, they're equal to h plus or minus a k. Center again is equal to always equal to h k, and your foci are equal to h plus or minus c k. So it's going to be the same thing as your horizontal ellipse. So another thing we can find is the eccentricity of an ellipse, and this is equal to, this means the deviation of an orbit or otherwise our ellipse being our orbit. And to find this, we just do c over a, so c divided by a, and that's how we find our eccentricity. So here's our hyperbola, and they're basically two parabolas, as you can see, facing away from each other. This right here, this axis is going to be called our transverse axis. And right here where these parabolas meet the axis, this is called our vertex, and is equal to h plus a k, which is also found on this side, except on this side would be h minus a k. And this is our center, as always, h k. And from our center to the vertex, this is known as A. The focus is found, so the focus will be found here in this area on the axis, and like I said, this is your focus, and the focus is equal to h minus c k when it's on the left side. On the right side, which would be over here, it's the same thing except for it's h plus c k. From your center to your focus, this is going to be known as c. Okay. So since this is a horizontal parabola, what you're going to use to find your equation here, your equation is going to be x minus h squared over a squared minus y minus k squared over b squared is equal to 1. And your vertical, if you're looking for a vertical hyperbola, you're going to use y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So you can see here how y goes first and x goes second here, while x goes first and y goes second here. So something else you can find here for a hyperbola is an asymptote, and the asymptote is a line that continually approaches a given curve but does not meet at any finite distance. So basically, your parabolas here will never touch these lines. These lines are considered your asymptotes. So the equation for a horizontal hyperbola would be y equals k plus or minus b over a x minus h, while for vertical it will be y equals k plus or minus a over b x minus h. They're just different in this sense, as here the a is over b and here b is over a. So here we have our circle, and in the middle this is going to be our origin or our center, and this is going to be h, k, and the distance from the outside of your circle to the origin is going to be known as r, your radius. And to find the radius, you can use the distance formula when you're trying to solve. So our standard circle equation formula is going to be x minus h squared plus y minus k squared is equal to r squared.